Today we are going to solve the question of the chapter 9. Read the first question, please.
Which steps would you use to correctly calculate the relative formula mass of sodium carbonate crystals?
Now, the formula of sodium carbonate crystals is Na2CO3 10H2O. Now, let's see what you have to do. The atomic mass of sodium is 23 because there are two atoms multiplied by 2. Put it in a bracket. Plus the atomic mass of carbon is 12 and there is only one carbon atom, so 12 is enough. Then plus oxygen, the atomic mass is 16 multiplied by 3, and then there are 10 water molecules. So what will you do? Plus 10 into, because there are two hydrogen atoms, so it will be 2 plus oxygen is with atomic mass of 16 multiplied by this 10 again. So this will be the answer. Question number 2.
X forms an ionic compound with the formula XCl and an M of 74.5 MR of 74.5. What is the MR of the oxide?
So XCl is an ionic compound, and if you remember, XCl is if ionic compound, that means X will be a metal, and its MR is equal to 74.5. How will you find the atomic mass of X? It's rather very easy. The total X plus Cl is 74.5. What will be X? X will be 74.5 minus Cl. Now Cl is 35.5. Subtract it, you will get 39. And find the element in the periodic table with the atomic mass of 39. It will be potassium. Next question.
An analyst found 0.6 grams of dissolved chlorine in a sample of polluted water. How many chlorine molecules are there in the sample?
0.6 grams
Yes,
of chlorine.
of dissolved chlorine.
Now 0.6 grams of chlorine. And the question is how many atoms or molecules?
How many chlorine molecules?
How many chlorine molecules? Now remember, the word molecule is very important here. Okay, 0.6. Now they are giving you mass and asking for the number of particles. What you have to do is divide it by 71. How is 71? Because chlorine molecule is Cl2. 35.5 is the atomic mass of one chlorine atom. Multiply by 2, it will be equal to 71. It will become number of moles. What will be the answer of this? 0.6 divided by 71. 8.4
multiplied to the
5
power of minus 3.
minus 3 moles. Now this is the number of moles of chlorine, and they are asking about the number of molecules. So multiply this by Avogadro's number. Multiply by 6 into 10 to the power 23. Multiply by 6. Just give me the answer of multiply by 6. No. Just 8.45 multiplied by 6.
50.7.
50.7 into 10 to the power minus 3 and 23 becomes 20. So it will be 5.07 into 10 to the power 21 molecules. Is there any answer like that? 5 into 10 to the power 21?
Yes.
That's the answer. Next question.
How many moles of ions are present in 142 grams of sodium sulfate?
Okay, sodium sulfate 142 grams given. It's rather, again, you have to change this one 142 grams into moles, and then you can change it into, okay, sodium sulfate. The formula of sodium sulfate is Na2SO4. Na2SO4 and 142 grams. 142 gram or 1.42? 142 grams. It is 142 grams. And what is the question?
How many moles of iron are present in 142?
How many moles of ions? Mole of ions. First of all, you have to understand that sodium positive ions and sulfate negative ions will be produced, and for every one molecule of sodium sulfate there will be 2 sodium ions and 1 sulfate ion. So in total there will be 3 ions for 1 molecule of sodium sulfate. Okay, now let's move on. Find the molecular mass. 23 multiplied by 2 plus 32 of sulfur plus 16 into 4 for oxygen. 46 plus 32 plus 64. 110 is equal to 142, which means this is 1 mole of sodium sulfate. From 1 mole, as I told you that there will be 3 ions from 1 molecule, so there will be 3 moles of ions from 1 mole of sodium sulfate. Answer will be 3.
You are told that 2.5 mole of oxygen gas has the same mass as 1 mole of SON. What is the volume of N?
Okay, now this is, you have to understand it. 2.5 moles of oxygen is equal to SON, and they are asking about the N. What will you do? First of all, find the mass of 2.5 moles of oxygen, which is 2.5 multiplied by 32 because it is O2. It will be 80. This 80 is the mass of SON. Again, subtract the mass of sulfur from it. 80 minus 32 is equal to ON. It will be 48 is equal to ON. Now oxygen is 16. So 48 divided by 16 will be N. So it will be SON3. That means number of N is equal to 3. Next question.
Potassium hydrogen tartrate has the formula. What is the percentage by mass of carbon in potassium hydrogen tartrate?
Okay, first of all, let's write the formula, and the formula is
C3H5
C3H5
O4
O4
C
COO
K.
K. And they are asking about the percentage of carbon in it. Please don't be afraid or amused by the long formula. Just write how many elements are there: carbon, hydrogen, oxygen and potassium. How many carbon are there?
4
4. How many hydrogen?
5
5. How many oxygen?
6
6. Potassium?
1
1. Multiply these with the respective atomic masses: 12, 1, 16 and 39. 48, 5, 96 and 39. 13, 19, 28, 6, 15, 18. Now the total mass is 188 and the mass of carbon is 48. So 48 divided by 188 multiplied by 100. Will you divide 48 with 188? 188 is equal to, so it is 25.5%. The answer. Next one.
1/3 of a mole of glucose has a mass of 60 grams. The empirical formula of glucose is CH2O. What is the molecular formula of glucose?
Okay, now they are giving you the trick part that 1/3 of a mole is equal to 60 grams. What will be the 1 mole? Mole will be 60 multiplied by 3 is equal to 180 grams. So 1 mole of that substance is 180 grams. And the empirical formula is CH2O. Find the mass of this empirical formula. 12 plus 2 plus 16. It will be 30. Now divide the molecular mass with this 30. 180 divided by 30 is equal to 6. And multiply CH2O by 6, you will get C6H12O6, which is the answer. Stop.